Um, my name is Christian Marussi. I work at Armin Kernel team. Thanks for having me. Today we're going to be talk about SCMI. That's not a big surprise, but was written there. So this is the agenda for today. It's pretty much tense because I want to have an overview in general of CMI very quick and then go deeper into the stack to understand what's going to be needed to be tested and try to evidentiate what are the problems. So it's very tense, but I should make it in 25 minutes if I don't brief too much. Maybe I can. So, okay, who am I? I'm Christian, working kernel team in SUDIP team. That is the team which takes care of firmware interfaces, but I worked mainly on SCMI in these last few years. So what is about? Basically, this CMI as a spec has evolved, the implementation has matured, and thanks also to the work of Linaro, ARM vendors. So this is good because they are using now, damn it. And so we have to test it even better. The problem is the thing is becoming even more, being distributed by nature, is becoming even more difficult to test all the stack. So this talk wants to be just a walkthrough for the current state of the CMI stack and just trying to see what are the issues, the shortcomings, but looking at the testing and development process and not about missing feature or stuff like that. So a word of advice, I drawn this diagram instead of stealing from ATG, so they are ugly. So the system control and management interface is a protocol. It's meant to abstract and unify how entity on a system speak to each other regarding control and power management. It's based on a client-server model. We have a server in the SCP CMI ARM reference. There can be multiple agents. It's OS agnostic, so you can really put some entity speaking a CMI and communicating with the server in any kind of, and they are effectively doing it. They are putting these agents in other firmware, in secure world, in normal world. It's extensible by design because a sub-protocol is dedicated for each single feature, let's say, that you want to support. And then the basic two ideas that I want to evidenciate, this is is certainly not a complete and full, it's just an overview of the CMI stack, of the CMI protocol. So the basic idea was there is a delegation of all the control action and policy enforcement to an external entity, which is the server, that lives somewhere, ideally isolated in some trust code base that is much smaller than the kernel. So we delegate that out of the kernel into some firmware. And like many other attempts has been done really by vendors, the CMI is an attempt to unify under one single standard. This should be good for security because no matter what you ask, the server has the last word and so can just deny your request or ignore you. So you can mount attack like corkscrew, which you tickle from a rooted system with the regulators or the voltage and try to do bad things. The other things is that being the CMI server, a central endpoint can harmonize all the requests. So if you have sharing the resources between agents and conflicting requests, the typical example is clocks, the CMI server can transparently take care to disable something only when everybody has requested the thing to be disabled. So this is good for virtualization purposes. So the thing is, as I was saying, that thanks to the work carried by Linaro, ARM, and also vendors, the stack has evolved, has matured. We added a number of transport beside the initial mailbox. SMC, OPT, FFA is in progress, I think, by Linaro, Virt.io. And so the server can be in a number of different places, not only on an SCP, on the microcontroller, can be in a secure app, in a secure partition, in a virtual machine. Sorry. And this, by itself, completely creates all the testing, because the stack is really distributed and you in a heterogeneous way. And so, moreover, there are a number of vendors that are built their own proprietary server. And each of these server have, by its nature, has its own defined implementation, its own implementation-defined characteristics. So you have a number of different things that you have to test, and you cannot easily refer to one single server for the perspective of testing the Linux agent. That is what I'm looking after. So here I want just to delve a little bit into the stack to understand where in the Linux we can test. What should we test? So at the top there are the classic drivers. These are SCMI drivers, CPU frac, clock. They are plugged into their subsystem, and basically they just relay requests, the normal request from the system into the SCMI stack. The SCMI protocol ops, that I don't know if it's so visible, is the outer API of the SCMI stack. And these basically are the methods that can be called, the only methods that can be called from the SCMI drivers. And each of these protocol, sensor, power cap, or whatever, they embed the knowledge of how the message has to be built for that specific thing to happen. But in order to send the message and track the message, comma, replies, delayed response, and stuff like that, relies in turn on the SCMI core driver that exposes some sort of ops. Inside the core, in turn, there are the transport I mentioned before, so that you can speak finally with the SCMI server at the end. So, looking at this diagram, we clearly want to test the server, and for this we have already a compliance suite, an ACS, usual SCMI test suite, so the entity at the bottom. And maybe we can do stress testing and fuzzing in the future. Currently, there's nothing about that. Regarding the client, so this bottom, this top box, what I would like to test is the protocol operation, of course. But I cannot use the yellow SCMI drivers, because those are real drivers that are plugged into the subsystem, and they only exercise in a limited way the protocol operation, and sometimes they are limited in what they can do by the framework itself. So you cannot, as a trivial example, you cannot issue multiple disable on a clock, because the clock framework will send a warning to you because the clock is already disabled. So that limits. So what we want to test is the protocol ops, ideally, and the core functionality. So the fact that the message is correctly built, sent, tracked back, the timeouts and the errors are catched. There's no attempt in all this, in the current situation, to test in isolation the transport operation at the lower layer, because those are implicitly used if you use the core, depending on how the system is configured. So what we did, since VC.3, 6.3, we introduced this interface that is basically sit on top of the core and expose a classical debug tree, from which you can just inject little endian binary SCMI messages, and that will be delivered by the core to the server wherever it is. Because the problem before was that we had to customize the test suite for every single transport we have, depending on the setup. And you have to configure the system for the testing. Instead, with this approach, we'll see in the next slide, you can basically just have a system that boots because it's properly configured, and you can run the test suite, and the core will take care to deliver the messages wherever the server has been configured. So yeah, I was saying testing, because compliance suite now has this raw mode enabled. You can use the debug.fs entries, and you don't care where the server is. And well, there is the note that I can only test for a normal world in this scenario, because Linux is a normal world, so that's one limitation. And then you can use this to write stress or fuzzing tools, to something trivial like that. So, and this give me the occasion to point out the first of the issue. If you test a real server on a real platform with this way, it works, but on an SCMI system, probably you will have many agents beside the Linux agents. So for your testing, it's not so good because you'll have interaction with other agents. You cannot exclude probably because that is a real system and that is how it's configured, the boot. So next is that we can use the SCMI row interface, this is already there, to test the core. Because what I want to make sure is that since this thing evolved, if you add new transport or if you have new, or we refactor something, I want to be sure that messages still properly delivered and tracked, and timeouts and replies, all of this. This list basically, that basic syncs, async comments, notification handling, timeouts, out of order replies, whatever the firmware gives me back, I want to make sure that Linux does not crash and is safe from that point of view. So you can do this in a number of ways. Recently, I experimented with a test protocol that is not official. I'm not sure that Shuvik is so happy. I proposed myself another protocol. But the point is, whatever you choose, in whatever way you choose to do this, you have to have a backend server that plays your game. Besides basic sync and async comments, that's the standard thing, all the other things are misbehavior. And hardly a real SCMI server is designed to misbehave because it's a product. And the other thing is that one of these scenarios is testing multi-threading. So, and that is an implementation defined property. So some server can have, some cannot. And so that's another issue with this kind of testing that is related to which backend server you choose to use. Oh, then there is the protocol ops that I mentioned before, here, the violet one. And here, basically, the idea was, this is a work in progress. I posted it once. I continue working on it, but it's really not posted again for a number of issues that I'll mention in a bit. Basically, the idea here is to get the whole SCMI protocol interface, which is this protocol ops, which is contained in SCMI protocol H, and exposes that through a dedicated driver in debugfs. So at that point, I can write millions of case self-tests because we love it. And this thing is meant also to ease introspection at runtime. If you are developing and you want to see what's the status of the resources, is useful because you can pick into the system live. On the other side, there is a lot to write and maintain. So this, together with the issue I'm going to tell you, makes me think, I don't know if it's worth. KUnit could be an alternative. I have not investigated if it's a way to use KUnit to test the protocol operation. So this is an example. Cannot be seen probably. We have debugfs and all the protocols, and under each protocol you have a resource number entry, after which you get all the, well, this is exactly the SCMI protocol.h content. So you can issue protocol operation, or you can register notification in a simple way. But the issue here are, again, what I have to use as a backend server. Because I need something, ideally, if I want to test in CI that implements all the protocol. This is not done on any real platform. For opportunity, or also for space concern, you don't have space to put all the protocols, even if I implemented. The other thing is notification, because some of these, like perf related, can be triggered by acting on the system. Some other not, like system power shutdown or sensor updates. You have to instrument the code, most probably, ad hoc to do this. And also, configure test expectation. I mean, if I write a test and I read something, I would like to know very well what I have to expect to that server in that specific configuration. Because if just I want to test for latency or stuff like that, I have to know what to expect. And the last thing is, if all of this can be done, maybe I will just kill the system if the server is misconfigured on the other side, or burn it completely. Or if not, anyway, the server will limit the capability, my capability of testing, because it will deny, as I said first, some of this operation. So after this, I want just to do a quick overview to what happens when the new protocols appear and how can we prototype it now and what are the issues here. So someone have an idea and the new protocol come by. And so ATG start working on a specification and prototype something on a VP or on a real platform. Anyway, it mocks something. Or this is done by vendor protocol, prototyping the protocol in their own server. At the same time, the test team in ATG wants to add new test case to a compliance suite. The kernel team want to start working on upstream. And the firmware team, again, same thing, want to plan for upstream for the new protocol. Now, all of this happens, as I saw it now, completely on different timelines and deadlines, as it's normal because we have different teams, different priorities, sometimes different companies, and I can't even access the vendor server that implements some protocol. So the problem with this, fundamentally, is that at some point ATG wants to release a beta. I want to write a driver somehow. But the worst thing is that the testing at this point does nothing to test their new test case for addition to the ACS test suite. Because there's nothing really that has been reliably developed. It's only prototyping in a number of ways. So my claim at this point is that the server side is not so complex from the process point of view, not in general. From the process development point of view, it's not so difficult because as long as you have a specification and the CMI row access, we saw before, you can just script something to send to exercise the server. Or if you're lucky, you can have an updated draft of the ACS test suite, and you can use that to interact with your server. You don't have to have any of the stack that I showed before, the protocols or whatever. Once you have row, it is already there. You can inject a packet in any way you need, and you see what happens with the thing that you are developing. Now, the agent development instead is very tricky because it needs some speaking entity on the other side that can reply dynamically to the request for testing all the things that I said before, both the protocol operation or simply the core and the message. So for this reason, I think, and the out-of-sync timelines between development, there are a number of ACK server, if you want to say it like that, a simplified server that sits somewhere. One is in U-boot. In TFA, I don't think it's official, but I saw it appearing. There is one in the test suite recently. There is my hack, the user space emulated mock server that I go deeper a little bit late, but just to see what can be done and not trying to sell that. Or there are the usual setup, recipe, a limited mocking, and queuing, or FVP. So what does this ACK simplified server in common? They don't have to cope with hardware. There's no abstraction usually, because, I mean, they are, if you want, quick and dirty. They get straight to the point, which is speak SCMI somehow. They don't have to support multiple architecture platforms compile everywhere, and don't need to be extendable. Don't have to follow any implementation defined choice. So it can be multi-thread, mono-thread, whatever you want. And usually the code base is small enough, and dirty enough maybe, to be understandable, so you can easily quick and prototype something. This is my hack. I'm not trying to sell in this, promise. The thing is just that what I use for my development is basically a Linux guest, a standard Linux guest, SCMI, speaking using Virtual transport. The KVM tool is patched, not upstream, to expose a Virtual device and snoop the packets coming from the guest and sending to a user space application through a Unix socket. That's bare what it is. Is heavily multi-threaded and everything is mocked. There's nothing real. So what are the pros of this approach that is similar to the other, it's just more wide? The tiny system is, the build system is minimal. It's just a few lines of makefile. It's multi-threaded, so I can test whatever interaction I want. There are no abstraction. I mean, I have some helpers just to make a bit of order in the code, but there's not layer of abstraction as should be in a real product. Everything is mocked. There's nothing to fry. The code base is small enough. I can really prototype a protocol in one afternoon. I can do whatever I want to the packet logic. I can make it misbehave how much I want at runtime. I can reconfigure it to trigger a notification I was saying before by asking with some experimental debug protocol, now send me this or send me that. I configure also the value that I read back from some other operation. So, and this is to set up. Now, this thing was useful because I could use it also in the past. At the end of last year, I was asked to do something different, SCMI. And so I went on FreeBSD. And so I was able to use this setup to run FreeBSD as a guest and emulate the server this way. Because in FreeBSD, the problem is even worse. I have only one platform implementing one protocol. So I just added Virtual transport so I can start working. Now, the good thing on all of this is that thanks to Rho, I can test for compliance this fake server or whatever fake server as much as I want. I'm not saying that I'm passing it now, but a few protocols are passing. So the other thing, okay, there are no other agents on the system. Now, the drawbacks, of course, are that there is massive duplication of work because I'm re-implementing something from scratch, even if very simplified. It's currently limited to Virtual. I can only test for normal work, as I said. And it's not performed as the QEMU-based virtualized SCMI just user that Linaro does. So at the end I was saying that is probably a different and worse way to set up a virtual environment for tests, respect to Linaro QEMU-based setup. That's for sure. I mean, the reason for this, are also historical because there was not the QEMU setup when I have these needs, so I started going this way. But the real difference for me that I want to stress here is that I use a simplified, stripped-down server. While if I use the QEMU setup that I prefer and is more performant because I have to use a real server. So I have, again, all the problem because I have the hardware, the real hardware, limited market capabilities, all that thing that I already said. So for me, the mother of all issue at this point is that if you try to use a real platform to do this kind of work, development testing, on the client side, you're going to have issues simply because you are using a product. And that has to support the platform. All the hardwares, all the instruction has to adopt some implementation-defined choice. Was not designed to misbehave, and most of the time does not support the complete stack. So, at the end, what we need, my claim is this, is just a subset of this functionality. So, a compliant SCMI-speaking entity that I can verify with a complex suite, of course, but does not need all the complexity of a real product. And again, I'm not trying to selling my solution. I'm using that, and I still will use that, despite this limitation, because it's what fits my case. But the other solution in U-boot probably are equally good probably for their test case. I could extend mine to cover more case, but so the core thing here that I want to the message I want to pass is that we could reduce at least the amount of work duplication, not saying to unify all the platform development, but if you have a pure library for a CMI, that is an idea that I know that has been floated around in the past for other reasons. So here I'm just adding a reason. I'm not pushing for anything, but I wanted to stress the fact that all of the issues that I can see from Linux perspective, especially in development and testing and in development process, comes from the fact that you use a real platform. Now, a unified virtual single platform probably is difficult to fit all the needs of all the developers, but maybe if you provide a pure SMI library, they can do what they want. Or they can put in their own product, if it's good enough. So something that basically can be plugged anywhere to retrieve the data, a mocked resource, or a real one, if you are in hardware, or it can be connected anywhere. And there's no logic for the scheduling of the messages, so I can play any trick on my own, or a real firmware can be configured instead to send the messages the proper way. And the good thing will be, beside all this thing about test and development, you could write unit tests at that point, up front, for the library in CI. I can, okay, I already said this now. You can base your preferred simplified server on that, and you can prototype on this possible generic platform based on this. You could prototype early on from when you start from ATG thinking about it. And instead of throwing everything away, then you can maybe refine that thing step by step until at some point you have some reasonably compliant server for that new protocol, and the test team can validate it in a reasonable way. So you will release not only the spec and the test, but also a new reference library with some support. That's pretty much of it. I'm very happy that I dropped this bomb and the time is up. So no question, thank you.
Just one question. So, are you testing also the fast channel method with that?
No, that's one of the things that was missing.
Okay. No, yeah.
That's one of the features. Sorry, that's one of the features that is missing. Probably was not there. The other thing is the other transport. Like if we want to use this to test the U-boot GPU open control thing, that is an agent that uses SMC. So we could think about extending this. I'd like to, if you can trap somehow the SMC and run U-boot plus kernel, but that is not there. I mean, I have ideas to do this for my own consumption.
Oh, yeah. Maybe we don't have the virtual supporting U-boot.
I don't know. No, I thought that U-boot was SMC, and that's the only way.
There is an SMC, but I don't know if they are supporting other transport.
That would be easier, if not. But I mean, the whole idea was, I did all these tricks for this reason, and maybe others are doing this. Well, I know others are doing this kind of tricks, and maybe we can solve it if we can do this step and deliver something like a library.
In the terminology of this presentation, is it possible, or maybe not allowed, is it possible to have two SCMI servers, or maybe more than one?
So that's a nice question. From the spec, the SCMI server is one. It has agent ID 0. So that's the only thing that is really mandatory. So if you put many servers on it, but the Linux agent, because you partition in channel, the same Linux agent speaks with multiple agents, is not really out of spec, but you have to take care if you do this configuration to let the server to let the server sync in the background on your own, because that is not covered by the spec. I know that someone is doing this. If you have this was mentioning, I don't know. The server is one from the perspective of the agent. If you put a lot of server or the same server speaking on many channels, considering the same agents as a different entity, because you give it 2 channels, he presented this morning, you can do it. Don't know if this was the question, really.
Is the agent, is it the property of transport somehow? Can the distinction...
The agents are identified through the channel through they speak from.
Yeah, can you
As
make
the
a
server,
distinction on the transport level?
what do you mean?
Well, you put something in shared memory, you send interrupts. In theory, you can direct a message to different SCPs, for example.
No, I'm not sure that you can do that, really. I mean...
Well, I mean, maybe it's not allowed by the spec, for example, yet.
Well, the spec presumes that there is one server, multiple agents, and the agents are identified by the channel through we're speaking from. So you're saying an agent could be sending a message through a channel and you redirect the message to another server?
You can send a message through different channels.
Yeah?
Yes.
Yeah, you know, this is what already happening. And these channels are connected to different servers, but from the agent perspective,
Yes.
you have to see just virtually one server, agent ID 0.
Yes,
It's not
so
that this server can have 2.
Is it possible to have 2 SCMI servers in such picture?
Well, I think people are doing this.
Oh, okay.
Is borderline, but is not out of spec. You should talk with Shuvik better than me in the architecture group. But if you maintain we're out of time. If we maintain the principle that the agent has ID 0, and this thing is completely transparent for, the server, and for the agent, so the server is speaking to him is completely transparent. The agent doesn't know if it's speaking with one server or the other. It's just speaking with a server, the only server. But through 2 different channels, you can send to different servers. But then is your problem syncing the server state in the background that's not covered by the spec.
Okay.
This is borderline, but can be done.
Can you handle different protocols by different SCMI servers?
So yes, you can assign different protocol permissions to different agents and also to different servers, but then you need to have a strategy for the coordination between servers, right? Because eventually you have to control hardware, if that makes sense.
So the server can become an SCMI agent as well.
I don't like how this is going.
It's getting more and more complicated. But there's nothing preventing that, but I think, it might increase complications. Yeah.
Okay, thank you.
That's all right.
Thanks.